Hello, this is Ms. Weimer again, and in this problem we're going to talk about writing an equation when we can look at the graph. And one thing that's significant about writing equations for trig graphs is that there are actually infinitely right answers. Unfortunately, there's also infinitely wrong answers, but excuse me, we're going to talk about a couple of the potential right answers or correct answers that you could come up with for this graph. So when we write a trig equation, we know we want it in the form of y equals a times either sine or cosine of x minus h plus k, which means that to write the equation, we need to decide if we're going to write sine or cosine, and then we need to find the a, h, and k values. So one thing that's nice about writing equations is that the a value and the k value are the same no matter which equations you're going to write, sine or cosine. So let's start by looking at those. And just like as if we were graphing, I think the easiest one to look at first is potentially the midline. And so when we're looking at this graph, we see that the high point is at 4, and we see that the low points of the graph are at -4. And if we split the difference between those, we would know that the middle is 0, which means that's where our midline is. So in the case of this graph, there is no shift for k. It's not shifted up or down. But because it goes to a high of 4 and a low of -4, the amplitude is the distance from a high point to the middle. So this distance right here that's equal to 4, that is the amplitude. Now, the k value gets a little bit trickier, the h value gets a little bit trickier because that's totally dependent on what graph we want to write an equation for, sine or cosine, and what we want to determine as our starting point of the graph. So I'm going to take this off of here just so it doesn't get confusing. Let's talk first about sine graphs. Okay, so we know that the basic sine graph starts at the midline and ends at the midline. And so when we're looking for our sine graph here, we want to look at where does it hit the midline. I see it hits the midline at pi over 2, 3 pi over 2, 5 pi over 2, and so on. The other thing that we want to consider for sine is that sine equation starts in the midline and it goes up first and then back down, right? So when we're trying to find that point as a starting point on our graph, we could pick this point as the start of the sine equation. So normally the sine equation starts at 0. Because the starting point has been shifted to the right pi over 2 units, we could say, if we're using a sine graph, that this graph has been shifted to the right pi over 2 units, so it's going to be negative pi over 2 for our h value. So that's one equation we could write. Whoops. Y equals 4 times the sine of x minus pi over 2, and then plus nothing, so we don't have to add anything at the end. However, that's not the only equation we could write. We could also consider this to be a sine equation that goes down first and then up, which would mean it would be a flipped sine equation or a reflected sine equation. And if that's the case, we could say that our starting point was here at 3 pi over 2. And then if it's flipped, that would mean that we'd need to change our a value as well and make it negative, and that the starting point has been shifted all the way over here to 3 pi over 2. So if it's a flipped one, our a would be different. It'd be -4. And our h would be different. It would be minus 3 pi over 2. So here's a second equation we could write. -4 times the sine of x minus 3 pi over 2. Midline still 0, still not adding anything. Okay, so those are two different sine equations we could write from this. We could also say the graph starts here at 5 pi over 2 and starts here at 7 pi over 2, so you have an idea of how we could potentially have infinite correct equations for this. We've written enough for now. Let's talk about cosine equations. So I'm going to erase this stuff, and we're going to use green for cosine. So a cosine graph, if you remember, starts at a high point, goes down, and then ends at a high point. That's a complete cycle of cosine. So if we're looking at high points on this graph, we're looking here at pi, and we're looking here at 3 pi. Those are high points. And so if we're doing a cosine graph that starts at a high point, we're looking at normally that point is 0, so it's been shifted over pi radians, which would mean if it's going to the right, it's going to be negative pi is the shift. So if we're writing a cosine equation, we would write y equals 4 cosine x minus pi. Just like sine, we could write a flipped cosine equation, which would mean it would start at a low point and end at a low point. If we're going to do that, the equation starts right there at 0, which is lovely, which means there's no shift. Or we could pick this point at 2 pi and say it's been shifted 2 pi. Well, let's use this one, because if this is our cosine equation, it means it has not been shifted. It's only been reflected. That means we're going to change our a value to be negative because it's reflected, but the other things stay the same. There's no h shift and there's no k shift. So our equation would be y equals negative 4 cosine x. So you can always check your work on these by putting the equations into your calculator and seeing if your graphs match the graph that you have a picture of. And if you're trying to write more than one equation, you can see if they match each other. But I hope you found this helpful. Again, breaking it down into those different parameters is usually the thing that's most helpful for me.